Hey guys, welcome back. In this video, we'll be covering about modules and namespaces. But first, I found a helium balloon outside. So let's see if it works.
Oh, yeah. All right. Anyway, we'll get started.
So
Today, it wears off really quickly.
about modules, to control complexity, large programs are always broken into functions, as we have seen in lecture 3. As programs get still larger, we need to further decompose the program into modules. So normally one file per module, and each module contains a collection of functions. So what it means is you can write a bunch of functions inside a module, but essentially this is just a Python file, and you can use that inside another program. And that's what we call typically a module. So any module can import the code and data from other modules. So you can have like a chains of modules being imported from one another. And the Python library is a large collection of modules, essentially. You can think it that way. Oh, my voice is coming back quickly. Great. So let's have a look how it's structured. So if I have already written some modules, so for example, some module.py and other module.py, and essentially I can save that inside the same folder if it's like a manually written. If it's a production line, what you want to do is store it in a specific folder and make sure the system has access to them by including the executables into what we call a path. However, configuring path isn't really part of this unit, so you don't have to worry about it. And all the items you need to do so will be configured for you. And in this module, in this video, when we write our modules, we're just going to put it inside the same folder as other programs that we're going to call them, so you don't have to worry about configuring the path as well. So importing module is very straightforward. All you have to do is write import and then specify the module's name without the .py extension. So here in this program, I can import some module and other module as such. And once those happens, essentially, whatever the functions inside those modules will be loaded into the program. That means I can use the functions inside my modules as if it's already written in my program. Okay, so let's have a look at some examples. A very simple example is the math module. So math module already contains a lot of functions and even some has constant values. And when we say import a specific module, what we're doing is we are importing everything inside. And also, we typically refer that as its namespace. So let's give that a go. Right, so I have this module for next slides ready, but here I can do import math. Okay, now I can look up help math. Then as you can expect, I have a very long list of functions and all the things that I can use now. Okay, so all of these are now available. I even have data. So if I type pi, math.py, then it will tell me the value associated with pi that's stored in the math module and so forth. So I can go print, essentially I should have gone print math.py. Okay, it tells me this. Print, also math has a square root function, so 23.456. Okay, gives me 4.84-ish, yeah. So here, a pi is just a value, so this is what we call an imported data value, whereas the square root is a function that we are using from the math module, so it's an imported function. Okay. Instead of importing the whole namespace, we could also import only specific items. This is sometimes useful in terms of performance if the module we're trying to use has a very large namespace, but most of the time we're not using them. So for our previous example, instead of importing the whole math module. Let's restart the shell. Okay, so here I can go from math import pi and square root. The only difference here now is that the math module itself isn't loaded here, so I no longer have access to math. Okay, and I can't do help math either because we haven't imported the math module itself, but we only imported pi and square root. Okay, so I can go help on square root because it's a function. Okay, and also I can use the pi value by itself straight away. So if you are importing selected data or functions, you don't have to use the module name in front with the dot. Okay. So as I shown you before, finding what's in a module is very easy. You could look at its documentation by looking at the help menu. So you just type help, open the bracket and pass in the module name. But you can also look at the Python documents online. Okay. Wings help menu as in this one. Okay, you can look up Python manual, Python websites and all that stuff. Okay. If you only want to look at a list of functions, then you can just use the directory. Import math and dir math. Then it's going to tell us all the functions related to math that we can access. Okay. Other than that, you can also Google it if you're unsure exactly the name or what you're looking for. And to get a specific help on individual functions, you can extend your help by typing the module name dot and the function name inside the module. Okay, so we have tried that before. So let's have a look. Not help, import help. So here we see log 10. Okay, so log 10 is a function. It tells us the return the base 10 logarithm of x. Okay, and there is also log 1p, and this one is the returns the natural logarithm of 1 plus x base e. Okay, so that's the natural logarithm function there. So that math module is a built-in module. Pretty much it comes with the Python package, but you can also create your own modules. Essentially, as mentioned before, any Python program can act as a module if it has functions and values stored. Right? So let's write our own module called circle. Okay, and you remember about the naming convention. The name of the module should represent what kind of functions and values we might expect from that module. Okay, so this is our module. This code here migrated to here, and it has two functions. One is area and one is circumference. Okay, so it's basically finding the area and the radius, circumference, the round distance. Okay, so what you have to do is save this inside the same folder as the program you're going to use to import this module. Okay, so what we can do is we run this, not run it. Here in my demo code, my demo code and the circle module is in the same place. So here, if I type circle, it hasn't been imported yet, but I can go import circle. Because it's in the same folder, it's not going to have a problem importing it, so there's no error. So now if I type circle, it tells me that this is a module, okay, located at this place. Okay, so now I can do r equals 5.0 to set my radius, and area equals circle.area r, because my circle module had an area function. I know I can do this. Okay. Circumference equals circle.circumference r. Okay, so those calculations are fine because those functions have been imported, although I don't have those functions in this particular code. So I can check the area and I can check the circumference, and those values should have been calculated correctly for us. Okay. Another point is that when you import a module, essentially what it's doing is it's running the whole module before running your own program. So import x causes Python to load and execute the file x.py. Okay, so remember to import modules, those files need to be in the path of the same folder. So I can write these code up here. Let's do that. Import circle, and then r equals 5.0, area equals, why am I doing this? Equals that and that. Okay, so I can run this. Okay, circle has been imported already. All those calculations has run, so I should have r value defined, area also defined. Okay, so I can do this in here as well. Okay, and of course documenting is very important, because currently if I go help circle, oh, actually no, yeah. So it tells me it's the name circle, it's got a couple of functions and the location of the file, but that's all I get really. The reason is because I don't have any documentation related to my circle module. So let's do that. Go back to the circle, I'm gonna comment this out, and I have the documented version over here. Okay, save this. Now uncomment this, run it again. Okay, everything's fine now, but this time we ran with the circle module which contained documentation. So if I look up help circle now, what we're going to see is whatever we had as a documentation, these documentation will be displayed through the help. So we have briefly seen this before. So name circle, and it tells me it's a module function related to circles, right? And this should map to our module docstring. Okay. And then each function has its own descriptions, and these are mapped from the function docstring. Wow. So this is essentially what we just checked, right? So you can try this yourself, and hopefully you get something similar. Okay. And a little bit more on import. When a module is imported, it is executed. So that's when the function object gets defined. Also, any module globals gets defined at this time. So pi was a global value from a math module. Okay, and if module has already been imported, basically nothing happens. Even if you edit to the module in the meantime, that means I could modify, say, math pi minus radius, or I could even just say return 0 for area, but here it has been already loaded, so I can type circle.area 10, and although I modified my module and saved, the module that has been loaded here is the previous version. So until I refresh my import, the changes that I made into the module will not be reflected in my current program. Okay, so be wary about the timing and making updates. Make sure you always save all your modules and programs to ensure that you're using the latest pieces of code. Okay. And when the module is imported, its name variable is set to the name of the module. So this has been confusing for a lot of people, but basically each program will have its own associated name variable. So here I typed name, and it tells me that this is main. Okay, so that means I can try print, so my own name, here, and I can print circle dot name. Okay, so and I run this again, then it's gonna show me the name of this program and the name of the circle program, and it tells me that wherever I'm running from, it's called main, and if I import it, then they get the name of their own file. Yes, it's still quite confusing, isn't it? So basically, if I'm running that program gets assigned name main. Okay, so if I'm running circle and I run this here, then the name of this circle program will be main, because this was the initial program that I executed. Okay, but in here I'm importing circle, so circle is not the main program that I'm executing, and therefore the name of circle is just circle. Okay, this is really helpful because now if you want to do some module test that when it gets imported by other programs, you don't want them to execute the testing code, then you can encapsulate the name by checking if the name is main. So if name is main, that means I'm actually running this module program. So I can execute my testing code, and if my module gets imported in other programs, this name will not be main, and therefore this code will not run. So let's give that a go. Comment this out. Oh, no, don't comment this out. Uncomment these. So now I created, if name is main, then I'm going to print area of 3, circumference of 3. So this is my testing code. So I run it as the circle, then I can see the area, it prints me the values that it's supposed to calculate. Now, without touching anything, I go back and run it here. I'm importing circle, but it's not going to show me the area of circle of radius 3, circumference of circle of radius 3 here, right? Because this name variable for circle is now circle, not main, and therefore this part of code doesn't get executed. This if statement becomes false. Okay? So hopefully that makes sense. However, if you're still confused, please do contact us in the labs or through the chats, and we'll try to explain this a little bit further as well. Okay, so what does the namespace look like? Namespace is really important because namespaces stores all the variable names and variables, functions, constants, whatever. And as we've seen a few videos before, a variable created inside a function has its own namespace, and the same idea applies to modules. If I'm importing module, it has its own namespace, but these namespaces will be imported to wherever you're working for. So namespaces are quite important important concept to understand, and this will become useful to you. So in your main program, what you have is this global dictionary. This is your main program that you're executing. And if you are importing, say, math has its own dictionary, like pi, square root that we have seen before. So this math, if I want to use square root, I need to go math dot and then access its own name directory, okay, dictionary. Then I can use those codes for square root or access the value for pi. Okay. So this is the look of how our namespace looks like when we imported math module. And if we do create some other variables like my age, it has its direct reference to the value. But essentially, if you're importing the module, it has its own namespace, which you can access through the module name. Okay. Local namespaces, so this is an important concept, right? Because you cannot access all the variable names which may not be public to other functions. Okay, so consider this following nonsense program. We have x equals 10, def blah x equals 20, print within blah x equals x. This function has its own namespace, and then print initially x equals that, blah, print post blah x equals whatever. Okay, what do you think the output is? Okay, let's check that. Yeah, where am I? Here we are. So let's hide our circles and check our blah. So we initialize x equals 10, so probably we probably say initially x equals 10. So that's what we probably guessed. And then we call blah. What happens in blah? X equals 20, and within blah, x will be 20. So that's what we would expect, 10 and then 20. And finally, once we finish blah, we go back to where we called blah and then print post blah. And here, this is the question. Is it going to print 10 or 20? Well, if you guessed 10, you're absolutely correct, because the variable x inside blah is not the same variable as outside blah. Okay, so when I say x equals 20, that assignment is not referring to the same x. Instead, inside my function, it has its own dictionary of variables, right? And then we have a new x inside the namespace, which gets assigned 20. So the outside x is not affected by x equals 20 inside the function blah. Okay, so that was the answer for this particular question. Okay, so to avoid that kind of conflict, you could use globals, but as we mentioned before, using global variables is not a good idea because you get a lot of confusions out of it. So if a function can see the variable in the global namespace and hasn't been defined in its own, then it will use it. Okay, so if I remove this and then run it, everything is going to be 10, right? So in the function, it doesn't know what x is. So what it does is go up to where it gets called from and then look up its space there. And if it exists, it will use it, and then we'll keep on trying to find that variable until it's not possible to find from the main function. Then it's going to give you an error. So for example, let's just say this is y, and I get rid of the first print. Then I'm calling blah straight away, and obviously name x is not defined because I haven't defined it anywhere. Okay, so the order of execution is, if I'm executing an expression, what it look for is look for its local namespace, and then it will follow to the global namespace if the name is not found, and finally it will throw an error if it is not found in the global namespace as well. So it's illegal to reference a global variable from within a function and then create a local one with the same name. So this is going to give us a problem. So let's say print x, and then what we're going to do is x equals 20. And this is not allowed in Python. It's going to give us an error. Local variable x referenced before assignment. So I'm creating a new variable called x, but I am trying to use it before this gets assigned. So if it sees that this namespace will be inside, but I'm trying to use it before it gets assigned, it doesn't use the global variable value. Instead, it will try to use the local one, and then it's going to complain. Okay, so Python interprets this as a local variable being used before it is defined. We say the scope of a variable is the entire function. Okay, don't worry too much about its meaning. Basically, it will try to use the local variable, and if it exists but it's not defined already, it will complain. So alternative way is to assign that I want to use the variable x from the global space. So what you can do is declare that this variable is global, say global x. So we can do that, global x. So what this does is that I'm declaring that variable x will be used from the global namespace. That means even if I have x equals 20, it does not belong to the local namespace. Instead, I will be changing the value of the global namespace. So if I run this now, your answer will be changed. So you can pause the video here and think about what the output might be. Yep. Okay, if I run this, the output will be great. Yes, so it's going to be 10, 20, and 20 instead of 10 because now we are manipulating the global variable value. Okay, So if I run this, now it's a 10, 10, and then 20 because we did a print before. We change it, okay? So now when I say x equals 20, this is directly referencing this variable outside because I have declared that this is a global variable. Okay, so now we have 10, 10, 20. But as a reminder, in this unit or in general, try not to use global variables as much as possible, although there are some few exceptions, right? Like constant values, global constants are good. So you should be encouraged to use those. So for example, recap from week 3 styles. For I in range 52, well, 52 may mean a lot of things. So maybe using a number of weeks, and then you define this once. And also you can have some sort of a constant value or like a threshold value. Those all should be defined at the very top of your program with all caps. Okay, so no confusions whether these are globals or local, just the random variables that you have created. Okay, so give them an all caps name at the top of the module, and these are called global constants, and these are fine. Okay, so now what we can do is create a global constant variables at the top like this. Okay, so pi over 2 is method of pi divided by 2, error tolerance is 0. Blah blah blah, and then I can use them in my module throughout, and if I need to update them, for example, tolerance may be updated, right? Then I can just go to the top of my module and change this value rather than trying to hunt for this value that I have used throughout the code. So that's it for this video. So hopefully it makes more sense about how the modules are structured and used, as well as understanding of the namespace and its effect between the local and global variables. Alright, otherwise I'll see you in the next video. Bye bye.